Hi everyone, good morning. Thanks for choosing this talk. I'm André Oriani, I'm Brazilian. I worked with Android since the very first public releases because at that time I was at Motorola. So I helped them develop their very first Android device, phones and tablets, including the famous Droid series. And I'm currently a tech lead at Walmart in California. So if there is any screenshot, any slide you want to take a screenshot, this is the one. This whole presentation was based on a series of articles I wrote about KMP and Swift. So all the content is there, much more details of this talk. So take your time and take a screenshot. Okay, can I move on? Okay, give them one more minute. All right, so let's get started. Kotlin Multiplatforms is awesome. Now, if you know some of Compose, Ktor, SQLite, and other KMP libraries, you can write not only an Android app, but you can also write an iOS app, a web app, and even desktop app from the same code base, and knowing little to nothing about all those different platforms, right? So isn't that awesome? However, in order to accomplish our secret goal of complete domination of the world of mobile development, we need to bring the iOS developers to our side. And how can we accomplish that? We accomplish that by writing KMP libraries that are so good, they won't even know they were written in Kotlin in the first place. And that's the whole topic of this presentation, how to write KMP libraries that play nice with Swift. But you can ask me, Andre, Kotlin and Swift are so similar. Why it's so hard to write KMP libraries that play nice for Swift developers, right? So if you ever try to visit me in California and you try to cross the Golden Gate Bridge, you're going to discover that you're going to have to pay a toll. And the toll here to cross the bridge between Kotlin and Swift is called Objective-C. So whenever you write your KMP library, your code is compiled by Conan, the Kotlin native compiler, will end up exporting an Objective-C framework. Then Xcode gets your Objective-C framework and bridge to Swift. So pay attention here. It's actually Xcode that's actually exposing your KMP API to Swift through this work of bridging between Objective-C and Swift. And that's where all the problems reside, because if there's a feature in the Objective in Kotlin that's similar to a feature in Swift, but is not available in Objective-C, that feature will be lost in translation. But you can ask me, Andre, why Conan doesn't just export a Swift framework, right? So there's many answers to that question. The main one is that the Swift interface, binary interface for Swift only became stable quite recently, whereas the binary interface for Objective-C has been stable for very many years, right? And the same way that someone will say to write a library for Java because you're going to be reaching the older audience, you also would do a library in Objective-C because then you can reach not only the people that are already using Swift, but the people that are still using Objective-C. So this is going to be the format of this presentation. So first I'm going to propose you some KMP API. Then I'm going to show how that API is exported to Objective-C, and then some Swift client code trying to use the exported API. But as you can see from this example, the Objective-C code is quite verbose and hard to read. So I'm going to provide you the translated version to Swift, right? So much cleaner, much easier to read, right? So pay attention to the icons. So Kotlin icon for the KMP API, Swift orange icon for the exported Swift API, and Swift UI blue icon for the client code. Okay, so the first problem we're going to talk about is name clashing. Whenever you see an extra underscore in your Swift API, it's because some name clashing happened. But why do they happen if everything was fine on the Kotlin side? So they happen for two main reasons. The first one is that Kotlin supports multiple namespace because you can always net packages. But Objective-C doesn't support namespace at all. Swift improves a little bit, but only supports one level namespace. That's the exported framework. So when you compile your KMP code, all your classes are going to be thrown in the same namespace. So if they have the same name, they will clash, even though they are different packages. Another reason for clashing is that whereas in Kotlin, the method signature is the method name plus the parameter types, in Swift Objective-C, the method signature is the method name plus the parameter names. So if you have multiple overloads in Kotlin of the same function that use the same parameter name, they will clash as well. So let's see some examples here to make things clearer. So in this first case here, we have two classes that share the same name, item, but they're in different packages, network and models. But because they have the same name, they will clash in Swift. So, but Kotlin tries to avoid the clashing by underscore to one of the classes. But which one, right? So here in this example here, item 1 is item from the network packages or from the model packages, right? So it's hard to know, even for the Swift developer. So what we can do here? So we can use this Objective-C name annotation that allow us to specify what's going to be the name, the symbol's name for Objective-C and Swift. So you see here in this example that we applied annotation. So now for Swift, we have very distinct names, item response and item model. So it's pretty clear to our Swift developer now which class is which. So in this case here, we have two overloads for the sort function. They use the same parameter name, data, but they have different parameter types. So this code here is okay in Kotlin because the parameter types are the same, different. But it's a problem when we go through the Swift side because the parameter names are the same. Again, Kotlin tries to prevent the clash by adding the score to one of the parameters. But which one? It's completely unpredictable, right? So there's two solutions here. The first one is, again, try to use the Objective-C name annotation. The second one, just use better parameter names. So this is a more curious example here. So here we have two interfaces, person and robot. And they both define the field ID, but they use different types. So person uses string, and robot uses long, right? In Kotlin, it would be impossible to have an Android class that implement both interfaces. The compiler would complain that you have conflict definitions for the ID field. But it's possible in Swift because, again, Kotlin will try to avoid the clash by underscore to one of the fields. So the same solutions here again. You can either use Objective-C name annotation, or you can just use different names to avoid this clash for your Swift developer. Now I'm going to talk about cases in which the type that you're going to see in your exported Swift API is completely different from the one that you specify in your Kotlin interface. So here's the first example. We have an interface product, and we have a class consumer, which has only one method consume, which takes a set of product. But then when we look to the exported Swift API, we see something different, right? So first, our interface product became protocol product. So interfaces in Kotlin will be mapped to protocols in Swift and Objective-C. Our class consume is still a class, but now our method consume is taking a set of any hashable. Where did those any hashable come from? And things get even more strange here in our client code because we can define a set of integers and pass through a method. This will compile. Of course, this is not going to work well in the runtime. But this works because integers are hashable, right? I mean, they're all their own hashable code. So what's going on here? So let me explain. So when you use set in your KMP API, this is going to be mapped to an NES set in Objective-C. And then Xcode will bridge that NES set to a Swift set. Swift set requires all elements conform to the hashable protocol, a Swift protocol, right? The problem, as already mentioned to you, is that interfaces in Kotlin are mapped to Objective-C protocols. And Objective-C protocols cannot be extended to conform to other protocols, let alone a Swift protocol like hashable. Therefore, our product interface will never conform to the hashable protocol that's required by SAT. So after type erasure, the type will be set to any hashable. It's the erasure type for hashables in Swift. But on the other hand, all KMP classes that you define in your code, they inherit from NES object, which conforms to hashable protocol. So the solution here is simple. We just make product a class, right? So we turn it into abstract class because interfaces in Kotlin kind of behave like abstract class when everything is abstracted, right? Because in the end, the only thing that can implement a class in Kotlin is, can implement an interface in Kotlin is a class. Protocols are a little bit different because there are many things in Swift that can conform to a protocol, not only classes. You can have structs, you can have primitive types through extension and other things. So they're complete different bits. But now we can see here that our consume method only takes a set of product. And even if we try again to pass that same set of integers, the code will not compile. We only accept a set of products. So the problem is solved, right? So here in this case, we are defining a line class value. I don't know how many of you already use a line class value, right? So that's one of the latest things that we see in Kotlin. So here we define inline class value postal code just to wrap the string, that's the postal code. And also we define a class letter that tries to use that postal code, that inline class. But then when we look at the exports of TPI, we see no definition at all to our post code class. And letter, now the field zip code is using any, not using post code. And any in Swift is anything at all, not only objects or classes. It can be primitive types, whatever. So here in this case here, I'm passing a UI view controller. For those who are not familiar with iOS programming, this is the equivalent of fragments in Android development. You can pass this, the code will compile fine, right? So the general advice here is don't use inline value class for a KMP class. Just use classes or just use the plain primitive type or strings. So now I'm going to talk about cases in which the export API in Swift is usable, but we can make changes to improve, to make it more intuitive to Swift developers. So our first example here, we define interface person, and we also try to define extension, full name for that class, for that interface person. But then when we look here to the code that was generated for the extension in Swift, we see that's pretty similar to when we try to use a Kotlin extension from Java, right? So we have this static function here that takes one parameter receiver. So I don't know about you, but I never liked this, used this way in Java, right? So pretty awkward. And I can guarantee to you that our Swift developer won't like to call like we would call in Java because for them, extensions is a very old concept. The Objective-C does have extensions. So for them to call the extension like this would be pretty unfamiliar to them, right? And the reason why this happens is because you cannot create extensions for Objective-C protocols. So Kotlin has to resort to the same trick they did for Java, that creating this static method. So what's the solution here? Again, is to use classes. So we define now person is a class in Kotlin, will be mapped to extension to a class in Swift. So then our Swift developer can use the extension the way they're expecting. Just call like extension, like a normal extension. Okay, so this is a more complex example. So here we have this in-range method that accepts a Kotlin range, right? So we are using Kotlin range here. This is an example of the calling. But then when our Swift developer tries to use the same interface, it's a little bit awkward for them because they need to create this Kotlin in-range object, right? So Kotlin So the trick here is to use this other annotation here, should redefine in Swift. Your method is still going to be available in Objective-C, but it's going to be hidden from Swift. Right? 2 underscores are going to be added to the name. Also, there's some extra annotations the Objective side that are going to make this method almost invisible to Swift. You won't appear in code completion for Swift developers. So you can see here in the very first right box that the class myRange, the method usingRange has completely disappeared from the Swift class. However, you're still able to write a Swift extension to myRange class that is able to take Swift range, convert to a Kotlin range, and then it can call the original method here. It's a little bit weird how you call the original method because, again, you have the 2 underscores, and also because this method is only available from Objective-C, you have to use the Objective-C convention to call it. So you have here the first parameter using range, and then the second parameter here, range. But you're calling the original method that you define in your KMP API. But in the end, after all this work, you have an API that's pretty similar to your Kotlin API, and your Swift developer can use Swift range like they would expect in the same way you would expect in Kotlin to use Kotlin ranges. So you don't have to write all your code in common main. You can have some code that's specific to a particular platform. So here, to illustrate that possibility, we are trying to create here an extension to Ktor URL class. I don't know if you guys are familiar or already play with Ktor. But I'm trying to create here an extension that will convert to the platform native URL type. So I don't have this extension in common main, but for Android main, I'm defining it to convert to a JavaNet URL. And for iOS main, I'm defining it to convert to NSURL, which thanks to bridging will be converted to a URL in Swift. So regarding default arguments, I have bad news for you. Default arguments are not supporting KMP, right? So there is a proposal to have something similar to JVM overloads annotation. I don't know how many of you have already used that. But until something similar happens to KMP, there's 2 solutions for that. The first one, you write overloads yourself, or you can use the library Sky from TouchLab that's able to generate all the overloads for you. So you can see here in this example, if you try to omit the ignore case or parameter because it has a default argument, the code will not compile. OK, exceptions is a curious case, right? Remember in Java, Java has checked and unchecked exceptions. So if the exception is checked, it must either catch it or warn that you may throw it by adding this throw clause at the end of your function or your method. Swift, Kotlin went complete away with checked exceptions, but Swift still kind of have it. So that generates some interesting results. So let's see one example here. So in this case here, we define this class bomb with this method explode that's definitely going to throw an exception. We see that there's nothing exceptional for the Swift code. And here in the client example code, we see that our Swift developer tries to be pretty careful placing this do catch block around a problematic method, trying to get the exception. But boom, the method crashes anyway, despite all the efforts of our Swift developer. And guess who you should blame? You, Kotlin developers, as is clear marked by the error message here. Function doesn't have on the right throws annotation, and thus exception isn't propagated from Kotlin to Objective-C Swift as an S error. So let's add a notation and see what happens. So in this slide, I'm going to have to do different from all the other slides. So in this case, I'm going to have to show you what's the code that's generated by Objective-C first. So it's going to be easier for you guys to understand what's happening here. So, OK, we add a notation. We warn that we may throw I/O exception. So then when Kotlin compiles that code, export Objective-C code, it completely changes the method signature. So we can see now here that method now is called explode and return error, and takes this pointer to any error object, right? So this is following the convention of the Cocoa libraries. The Cocoa libraries are the libraries that are used, like UIKit or Foundation, that are used to develop iOS apps. And the convention is in the Cocoa libraries that if a method can generate errors, its last parameter will be a pointer to any error object. So if that pointer is null, the method has succeeded. If not, the method has failed, so you can expect that object to try to understand what happened. And then when Xcode C, Object-C methods that follow the Cocoa convention, they will map those methods to methods in Swift that they can throw any error. So we can see here now in Swift that the original signature of the method was restored, so method still call explode, but it has this throw annotation, this throw clause at the end, so warns a Swift developer that this method will throw annotation. So now our Swift developer is not only able to cat the KMP exception, but it's also able to use this extension to NSA or Kotlin exception to recover the original Kotlin exception and be able to properly handle the error. Okay, now let's see how enum and sealed classes are mapped to Swift. So the problem with Kotlin enums is that Objective-C only supports C-style enums. Enums in which every element of the enum is mapped to an integer constant. So whoever programmed here in C, C++, and other old languages know that that's the only possibility you have for enums, right? But we can see here that Kotlin tries to do a good job in trying to emulate a Swift enum, right? By having this result class inherit from Kotlin enum, and then every element of the enum is now a constant instance of the enum class. So we can see here, I don't know how many of you are familiar with Swift, but the syntax is pretty similar, right? So you have this dot enum element, right? But the problem is because there is no way for Swift to know that load and success and failure are the only possibilities of your enum. You have to provide this useless default clause here that's never going to be called, right? Because switches in Swift, like when in Kotlin, are exhausted. So you have to provide all the cases. And things are not better for sealed class. Sealed classes are the closest thing we have from Swift enums, because in the same way we can define a sealed class hierarchy to work like enum and pass some data, we can do the same thing in Swift. So sealed class would be the same thing, would be the closest thing to Swift enums. However, again, there's no way for Swift to know that Swift doesn't know anything about sealed class. So you're going to see your sealed class hierarchy as any other class hierarchy. So your Swift developer here, we have a pretty hard time trying to downcast to the correct class. And again, it's still going to have to provide this default clause, because again, there is no way for Swift to know that's their only possibilities of subclasses for a result. So how can we solve this problem, right? So remember what we did for the in-range code, right? So we have a feature in Kotlin that's pretty similar to a feature in Swift, but that feature is a descent from Objective-C. So here, we're going to have to write some Swift code to cover that gap between Kotlin and Swift. So that's exactly what we did here. So we define a Swift result enum to replace our enum or sealed class, right? Because if you give a Swift enum to a Swift developer, it's business as usual for them, right? And then I did here one of the craziest things that I learned about Swift. So in Swift, you can add new constructors to classes through extension. And the craziest thing, too, is that those constructors can return new. They're null here, right? So two things are completely impossible in Kotlin. So So here then, we just define this new constructor to sweep the result or replace enum that we basically take our Kotlin enum or sealed class hierarchy and convert to the Swift enum, right? So that's exactly what we do here at the top, right? So we just pass our Kotlin enum or Swift enum. That converts to the Swift enum, and if we give a Swift enum to a Swift developer, there's no secret for them, right? But then you can ask me, okay, do I have to learn Swift now? And do I have to write Swift enum wrapper for every Kotlin enum or sealed class I have on my KMP code? No, you don't need to do that. So there's already libraries that generate that Swift wrapper for you. So namely, Moco K-Swift and Sky from TouchLab. All right, so generics. Generics were introduced in Objective-C in 2015, right? And the only reason they were introduced in Objective-C didn't have them before, was to improve the interoperability between Objective-C collections and Swift collections. So before lightweight generics, your Objective-C developer would declare any SRA, but would not be able to tell what that NSRA contains. You would not be able to say, okay, this is an NSRA of integers. And then when that code was mapped to Swift, your Swift developer would get a list of any, right? And then they would have the hard time trying to figure out, okay, they need to force cast any to some class. They would have to talk to Objective developer to figure that out, right? And similar things to other Swift collections. So you have any S dictionary in Objective-C that's mapped to a dictionary of any hash bowl to any. And SAT, as we saw in the very first slides, is mapped to a set of the any hash bowl, right? But then after lightweight generics, or Swift developer or Objective-C developer is able to specify, okay, in this particular case here, this is an SRA of the S URL. And thanks to Swift bridging, is now mapped to a list of URL, right? But because lightweight generics were only introduced to solve this particular problem, improve the interoperability between Objective-C collections and Swift collections, they only support classes. So let's see some examples to make it clear. So here we have interface cat that defines only one field data, right? It is a generic field. But here in export to Swift API, we see that now our interface, as I already told you, is going to become a protocol. But protocols do not support generic. So our data field is going to be mapped to any, with these anything at all. And it's going to be any nullable, right? So you can improve this to say that's not nullable if you bound T to N. For classes, okay. If we define a generic class in Kotlin, it will be mapped to a generic class in Swift in Objective-C. But the problem is going to be bounds. If we try to define a bound, that bound does not be respected. So you see in both cases here, in Bird, we try to bound our generic type T to number, but that's going to be completely ignored. It's going to still be bound to any object, with in Swift means is a pointer to an object. Much like object is a pointer to an object in Java, or any is a pointer object in Kotlin. So generics are not support for functions and methods, but there's some interesting here that happen when you define bounds, and depending where those bounds are, classes that are defined by you, or types defined by you or by someone else. So here in the method drink, method eat, we are bound T to a number. Number is a class defined by the Java standard library, but we see here that the parameter is mapped to any, right? So the bound is ignored. But on the other hand, my interface is a type that was defined by us in the method drink. So now we see here in the export to Swift API, that value is point to my is the type of my interface, right? So we see here that there's no support to generics, but at least there's some respect to the bounds of the types. Okay, approaching the end. So now let's talk a little bit about flow and coroutines. So if you have a suspend function in Kotlin, that function will be mapped to a function in Objective-C that uses completion handler. Completion handler is just a thing's name that Apple created for callbacks. And since Swift 5.5, Swift supports async functions. And then after that, whenever Xcode see a function with completion handler in Objective-C, it will map to a async function in Swift. So that's the reason that even though we define only one generate integer function method in Kotlin, we're going to have two versions here. The original version from Objective-C that uses completion handler, and the new version from Swift.5 that use async functions, right? So I'm not going to show you here how to use the callback version because I think everyone is fed up with callbacks, right? No one wants to create a param doom here or a callback how. So I'm going to show you how to use the sync version. So use async functions in Swift is pretty similar to use coroutines in Kotlin, right? So you have to create a task, which is pretty similar to create a coroutine scope and a job in Kotlin. You're going to have to use this await keyword that's pretty similar to call your async function. That's pretty similar to using launch or async to call your suspend function, right? But the difference here is that if you call cancel in your task, that won't cancel your coroutine. And the reason for that is that this method it was created by Xcode, by Swift, which has no idea that you're using Kotlin coroutines, right? So the cancellation here is not propagated to the KMP side. And for flows, things are not better, right? So besides not being able to cancel your flow, state flow, shared flow, they're all defined as interfaces. And you just learned that interfaces do not support generics. So we can see here in the export of the API that your Swift developer will get the flow, but they won't be able to know that this is actually a flow of ints. So how can we solve this? So the solution is actually complicated because it requires you to write some Kotlin code that will wrap your flows and your suspend functions. And the Swift side, you're going to have to write some code that will patch between, that will create this connection between the Kotlin coroutine and the Swift task. But fortunately, there's people that already work on this and develop libraries. One of the libraries is Sky by TouchLab. And the other library is KMP native coroutines that I'm going to talk about here. And KMP native coroutines recently received a grant from the Kotlin Foundation. So using KMP native coroutines is pretty simple. All you need to do is that for the scope, the coroutine scope you want to use in Swift, you just need to annotate with native coroutine scope. And then all your suspend functions and flows, you need to annotate with native coroutines. And then the changes for your Swift developer are going to be minimal. So you can see here that the only change your Swift developer are going to do compared to calling a normal async function would be that first they're going to have to import this KMP native coroutine async framework. And then to call your original suspend method that now is a sync function for them, they need to call this async function. This is the method this is the function that's going to establish the connection between your Kotlin coroutine and your Swift task. So now when you call cancel in your task, so when your Swift developer call cancel in their Swift task, that cancellation will be propagated to the KMP side and will cancel the coroutine job. For flows, there are many options, right? So one of the options is to convert your flow to Rx Swift. But in the same way we're moving from XJava to Flow and coroutines, Swift developers are moving from RxSwift to Combine, which is a framework, is a publisher-subscribe framework defined by Apple. So here we're going to show you how to convert your Flow to publishers to Combine. So again, it's pretty small number of changes, right? So besides import the Combine framework, you're going to have to import the KMP native coroutine Combine framework. And then all you need to do is to call your Flow with create publisher. We'll convert your Flow to a publisher. And then after that, it's going to be business as usual for your Swift developer. All they need to do then is just to eventually call sync, which is the equivalent for subscribing RxJava or collecting flows. And the good news in the end is that if you cancel your publisher, that also will cancel your flow on the KMP side. And that's all. If you found everything that's said here too much complicated, just use Kotlin Multiplatform. Then you can write your entire iOS app just using Kotlin, and you don't have to worry about Swift developers or Swift.